This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make wind turbine lightning protection easy. If you're a wind farm operator, stop settling for damaged turbine blades and constant downtime. Get your uptime back with our Strike Tape lightning protection system. Learn more in today's show notes or visit weatherguardwind.com/striketape.
Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back to the Uptime Podcast. I'm your co-host, Dan Blewett. No Alan Hall today, but we've got a great guest, Dr. Thomas Schlegel. He's the founder and managing director from Eologics, and they are an ice detection sensor company with some really interesting IP. So we've talked about in subsequent episodes, the whole Texas, ice disaster from January of 2021, and we've covered it from different angles. We talked to Brian from Elemental Coatings, talk about some upcoming, ice shedding coatings that allow ice to slough off a blade a lot faster. We've talked to Lasse Hietiko from Weisstech with their blade heating technology. And so we've gotten a good idea of some of the different ways to keep ice off your blades. But today their technology at Eologics is about ice detection. And, this is going to allow operators to automatically stop and start their turbines when it's, safety regulations tell them that they have to. And if they don't have a heating technology, that's going to be their solution, right? Is to stop their blades, wait till, tomorrow it warms up or the next day or whatever, and then get them operating again. And that's going to make the most sense for a lot of climates and some wind farms. So Eologic has interesting technology. There's essentially it's almost like a big sticker. They can stick it on the blade. You could put it on every turbine in your site or a handful, depending, just on what's going to be best for it. And you could also put it on potentially turbines that are closer to, say, a residential area or a trail or somewhere where, again, there might be more human safety concerns from ice getting thrown, et cetera, et cetera. So, one of the things that makes this tech pretty interesting is that it's not measuring just atmospheric conditions and sort of predicting or guessing, but it's actually directly measuring the ice accumulation on the blade. So this is unique to their company, to Eologics, and it's something that potentially could really be a game changer for wind farms that are struggling with having to send technicians out to manually stop and start the turbines, and they're just maybe not getting the quality of data that they might otherwise, get from something that's actually like a direct measurement, not just, again, an atmospheric or ultrasound kind of measurement. So again, really interesting conversation with Thomas today. So without further ado, let's go to Thomas Schlegel, managing director and founder of Eologics Sensor Technology. All right. Well, Thomas, thank you so much for joining us on the show today. We're really excited to talk more about this wind turbine blade icing issue.
Thank you, Dan. Thank you for being here in the show.
So let's get going. So obviously Texas had a lot of icing problems back in January of 2021. There were huge power outages, right? We've talked about this on the podcast here from a bunch of different angles with blade heating technology, coatings that can help reduce icing from Elemental Coatings. Lots of different avenues we've talked about this problem because it was such a big deal, in the U.S. when that ice storm hit. But what we haven't really talked about is ice sensors. And so you are with Eologics, and you guys have some pretty unique intellectual property, and your technology is actually really fascinating. So can you take us through a little bit about why detection is so important? Because everyone thinks about, we need to keep ice off. Does it even matter that we know it's there? We just need, why don't we just blast them with heat all the time? But it seems like the detection is just as important, if not more so important, than actually having the heating in place. But can you take us through that a little bit? Why is detection so critical for keeping these turbines optimized?
Yeah, actually, from our perspective, our point of view, the detection is actually where everything starts, right? So you need to detect ice to be efficient in removing the ice. that means, I mean, as you said, might be possible to like heat the blade all the time, which is really costly and not really efficient. But knowing that your blades are iced, and that's the very first very important point, to know that your blades are iced is the first step to then take counter steps to avoid or remove the ice from the blades.
And so there's been a lot of different types of technology. What right now is so different about your sort of stick-on, epoxy-on solution with Eologics? What's different about it?
It's actually the direct measurement. So as I said before, you want to know the ice on the blades. It's not enough to know that the temperature is below zero, or maybe there is some moisture in the air that you have icing conditions. The very important stuff is that there is ice on the blades, and to be accurate with the measurement. And the accuracy you only get with direct measurement on the blades. So all the indirect measures, like measuring on the nacelle or measuring vibrations of the blade or comparing the power output of the turbine, like the power curve changes, it's just too inaccurate to be really efficient with blade heating or countermeasures against icing. And that's where we at Eologics say that the direct measurement is, of course, the most efficient way and also the most accurate way to detect icing on the blades.
So can you take me through the other ones? And we don't have to get into like your actual, competing companies, but just what are the other different technologies? So you just mentioned atmospheric conditions. You can measure those. So, we pretty much know when the cocktail is right for icing, right? If it's a certain temperature, certain level of moisture in the air. But you also mentioned vibrations on the blade and ultrasound, stuff like that. Can you give us kind of a quick overview of all the different types of ways that we as an industry have been detecting ice?
So which is what is really long on the market are the nasal based measurements that starts with anemometer comparison. So you have a heated anemometer and a not heated anemometer, and if the one that is not heated starts to change the rotational speed compared to the heated one, then you suggest that there is icing. The other one is a vibrating wire, which is placed on the nacelle, and if this wire starts to ice, then this vibration frequency changes. And again, it's indication for icing conditions, and it's not yet saying that there is icing on the blades. The other thing, which is blade-based, is the vibration measurement stuff on the blades, where you measure the vibrations of a blade, you calculate eigenfrequencies, and if the weight of the blade changes, the eigenfrequencies change. And with this eigenfrequency change, you again say that there has to be ice on the blade, because why else should the weight of the blade changes then because of ice? So I think that's the most common ways of detecting ice. So the nasal based, which are there since I would say beginning of the 2000 years, and then you have the vibration based system, which started a little bit after 2010.
Okay.
And that's where also Eologics started in 2014 with the direct measurement on the blades.
Gotcha. So I want to get back into why detection is so important. But first, let's go more into what Eologics does. So yours is direct, and it's a lot like, to me, it almost looks like one of those really high tech bandages that you put on like a burn or something, where you're applying it to the blade. It's got good, like sticky back adhesive. You're going to edge seal it, so it's going to be on there. But what are the key pieces? Without, obviously, I know you have some pretty interesting intellectual property, but what are some of the unique things about your sensors?
The nice thing is actually, and that's maybe the size of the sensor, that it's really thin. So we are below 2 millimeters of thickness. That means that the sensor is flexible. So, and it's completely wireless. It's about the size of a hand, and as you already said, they are sticked like stickers on the blade. Because they are so thin, there is no aerodynamic effect, and they are directly sticked on the outside of the blade. as they are completely wireless, they have to get powered somehow, and we use flexible solar cells on the sensors that power the sensors. Additionally, there are batteries on it, small battery packs for complete dark times, and that's really only necessary if you way up north. So we have installations north of the polar circle where you have more than maybe months of only gray daylight, where you get where you get less ambient light, and there you need this battery backup. Without
Okay, so
any light.
so you've got some redundancy in there, it sounds like.
Exactly. And then you have the measurement area, which is based on a capacitive measurement principle. That's similar. Actually, it's the same measurement principle that all the smartphones, like your Apple phone, uses to detect that there is a finger. And we use this technology to detect the ice, and not only the ice, but also the ice thickness and the type of ice. So we can also distinguish between light rime ice and heavy high mass glaze ice.
Okay. So it sounds like, you said it's really thin. It's not going to really affect aerodynamics. How is it going to hold up to some like leading edge erosion? Because obviously that's one of the big things. We have a couple robotics companies coming on the show. Everyone's trying to repair leading edge erosion, get ahead of it, prevent it. Is yours going to get eaten up by, years being on the blade? And it seems like obviously yours has got to perform really well in some pretty brutal conditions.
Yeah, we're not really directly on the leading edge, although on the pressure or suction side, but the erosion happens directly on the leading edge, and ice accumulation normally starts a little bit off the stagnation point, and that's where the sensor is located. And additionally, we are placed below an erosion protection tape. So the whole sensor comes below a 3M erosion protection tape, and that's also protecting the sensor against erosion.
And so, I guess like the practical application here is that when and these sensors are connected to the turbine itself, where it'll just automatically start and stop it when it's got ice. Is that right? Or is it just alert somebody and then they've got to take action? I mean, what's the latency there as far as detecting ice, and like what's the action item of the sensor itself?
The nice thing with the sensors is that as suddenly as they detect ice, they not only say ice yes or no. So we have several sensors on the blades, and each sensor is delivering the thickness level of ice. They are transmitting the data to a receiver. The receiver is located in the nacelle, and usually it's connected directly to the controller. The turbine controller then reacts on the signal of the sensors and either stops the turbine, or, and that is also very important, can automatically restart the turbine after ice conditions. Additionally, you have the possibility to control heating solutions. So if you already have a kind of cold climate package on your turbine and you have a heating, you can use the sensors as it can be really sensitive. You can also realize functions as predictive heating. And of course, you can use the data from several turbines to predict like big icing conditions. What we have, for example, as you said in the introduction, in Texas in January, we are doing that actually already in Austria with the grid operator to give him information if several turbines have to be shut down due to icing, and maybe further more turbines are coming to a shutdown, that this gives the information for the grid operator that soon there will be turbines going off the grid. And that helps for preventing such power losses in the grid.
Okay, yeah, that makes sense. So I guess if people are trying to taper down and say, okay, we need to divert power from here and get more from here because we're going to lose a couple of turbines, and that makes good sense to kind of get ahead of it that way. I hadn't really thought about that prior to us talking, but that makes a lot of sense. Where like you said, you have a little bit of a predictive gap to get other power sources to the forefront, if you're into that potential like big time ice situation. That makes sense. Well, are you guys partnering with like other companies? Because it seems like this whole thing it's not just like this is the only thing you need to prevent blade icing, right? It seems like there's lots of different tools, and I know we're going to have, I think one of our previous guests back on the show to talk about aerodynamics and how power curve upgrades could even help keep them going when they have a little bit of ice accumulation on there. But like, I mean, how do you view this sort of whole ecosystem of like blade heating technologies and your sensor technology and maybe like even the coatings, like, which is really cool and sort of on the up and coming with elemental coatings. I mean, how do you see that whole thing working to where it makes like good financial sense? And do you see like all this changing where it's going to be relatively easy with new technology sort of working together to keep these, to prevent another Texas situation from happening?
I mean, I think they have to be easy working, otherwise nobody will use them. And in terms of partnering, we see Eologics, or especially the sensors, as supporters for several other companies and areas for this cold climate package. So of course the OEMs, the manufacturers of the turbines with their heating solutions, the sensors can be supportive for efficient controlling the heating solutions, for ice detection, as already talked about. But also companies like WiseTech was in the show before, right? So we are cooperating with them. Also, additional heating solutions. We use the sensors for temperature control of the heating solution. So all these conductive heating solutions normally are pretty sensitive. They are high efficient, so they can heat up really fast, but they are also not allowed to get too hot, right? And a sensor like our sensor that is measuring directly the surface ice thickness, but also the temperature, can help there to control these features. Of course, you have also the coatings, and here our sensor can easily be placed below such coatings. So we already were on winglets of blades below these anti-ice coatings, just to prove that they are really not affected by icing.
And so as far as like regulations, I mean, I'm sure depending on the climate, depending on the country, like there are regulations in place, right, for icing and when the turbines need to be shut down. Can you go into that a little bit? Because obviously no one wants to be chucking, 2-kilogram pieces of ice, into a neighboring community, like, and that's very realistic because of just how powerful these turbines are and how fast they spin. So what are the implications for stopping and starting, the turbines safely, and like what are some of the different regulations that have to be met?
That's really country dependent, and even in countries like Germany, it's even on a smaller region different. But as you said, most of the times it's a safety issue that comes with the regulations. So you're not allowed to operate a turbine if there are some safety issues. What is not allowed with ice is exactly the safety issue. So only rime ice, a white shadow, white thin level of ice is allowed, because if it goes down, it's more like snow. But you're not allowed to have glaze ice on the turbine, as you said, 2 kilograms of an ice ball falling down and maybe throwing more than hundreds or 300s of meters away is definitely nothing you want to have. And yeah, there the regulations normally force the end user or the operator owner of the turbines to use an ice detection system and turn off the turbine if there are some safety issues. And that's actually the regulation. And then it's up to our customers or to the owners of turbines how they mitigate these ice risks.
And then, I mean, what's the most common thing at the moment? So when we talked with WiseTech, like most turbines don't have blade heating, installed at the moment. And of course, there's, much of the installed capacity around the globe isn't going to be in a place where they're even going to need it, right? There's tons of them in warm climates throughout the year. But do most turbines that have some sort of ice detection, is their thing just to turn them off, and that's like their solution? Like, we're just going to shut them off when they're iced, when the ice falls off or just like melts, when the conditions improve, then we just turn them back on. Is that pretty much the current solution for most wind farms?
I think that's the majority of turbines do have these solutions. And as soon as the downtime due to icing gets high enough so that the economical pain, if you put it like that, is high enough, then like heating solutions going to be an option. But the majority of turbines, as you said, don't have a heating solution, and if you have days below 0 C, you might have icing, and then the first thing you have normally is an ice detector to turn off the turbine and then stop it. And when the temperature is above 0 again, or the ice is gone, you restart the turbine again. Then it's a question of the number of events you have during a winter. Sometimes it's okay to manually restart the turbine because it's only a few events over the winter. If it's more than a few events, you might want to have an ice detector that also automatically restarts your turbine because you don't want to do it manually all the time.
Yeah, that makes sense. So this is going to prevent, your sensors will prevent them having to send a technician out there, that they can just do it from like a control room. Is that right?
Exactly.
And then, so like we talk a lot about data on the show. Our co-host Alan, who's not here today, loves data. You know, Alan's a huge data guy. So I feel like in his honor, I should ask you about data, because everyone, it seems like, has their own dashboard, or they're pumping the data where it can be accessed by the operator or the technicians or whoever. So I mean, what do you guys do as far as data? Is it really important in this case, or is it really? Because to me, it sounds like, and this is just an outsider's view, that as long as the sensor turns it off when it needs to be turned off, turns it back on when it needs to be turned back on, it seems like it might not need that much of like a data dashboard. But is my view right or off there?
It's again depending on the customer. So there are many customers that are, hey, if the ice detection is working and it turns off the turbine and it restarts the turbine, then it's fine. I don't need additional data. And then there are others who are maybe also bigger customers who want to do their own kind of research, want to evaluate icing on the turbines, want to know what happens on their blades. They at least want to have the data because normally SCADA data in the turbine is not accurate enough. So for these ones, we of course also offer kind of a dashboard or an API for connection to their second level SCADA system, so they can have all these data, like data from each individual sensor with each individual ice level and temperature value. But that is really customer dependent.
Yeah, gotcha. And then I'm assuming that this is something you'd want to have sensors on every single turbine. So if you have a wind farm with 60 turbines, you'd want sensors on every single one, or is it just like on a couple? How does it work as far as the layout goes?
I mean, as a Ologics, of course, preferable would be sensors on each turbine. But to be honest, it also depends on the terrain. If it's like a complex terrain where the turbines really ice differently, then it makes sense to have it on more turbines than maybe only on the corner turbines. It's sometimes also a regulation topic. Sometimes you need to equip the turbines that are close to a road or a path, a trail, with ice detectors. And sometimes the customer really only wants to take the corner turbines, and if these corner turbines ice, then he shuts off the whole wind park.
Oh, so and so when you mentioned that, maybe if they're close to a trail or something, is that just because they'd have more of like the potential to throw ice towards, people? Is that right?
Exactly. Like a trail where some bikers or people going, you don't want to have ice throwing down on the trail, right?
Yeah, and it's weird because when I think of like a wind turbine throwing ice, to me, like, there's not many things in life that actually throw ice, right? Like, an icicle might fall off your building. But in general, like, you never come across, at least in like a normal person who's not working in like a heavy industry or something, like any kind of like dangerous ice. But I mean, we're talking about chunks that are like multiple kilograms, where it's essentially like throwing a brick, right? And that's what I've been thinking about. Like, I live in DC and there's tons of brick sidewalks and streets and stuff. And the idea of like a wind turbine chucking a brick across like a neighborhood is terrifying. Like, that really could kill somebody. Yes. But for me, it's like hard to get into that mindset of like, oh, just like chucking some ice. You think of like, again, like some ice sliding off your roof, like no big deal. It's like a little sheet of it. But That's not really the case. It's really like super dangerous. Again, like chucking bricks across my neighborhood. It's like you're under fire almost.
Yeah, exactly. And you have to imagine that the tip of a blade is like moving with more than 200 kilometers per hour. So I don't know what's that in miles per hour, but pretty fast. And if the ice falls off at the right moment or throws off at the right moment, it really goes far, right? So we're talking really
Yeah.
about 100, 200, even 300 meters. And then maybe from a height of 200 meters, that there is a lot of force behind it, and you don't want to get that on your car either.
Yeah, which I do want to see this in action though. So if anyone has a video of a turbine throwing a brick-sized piece of ice, please email it to me because that would be fascinating. You know, like as kids, you look at like trebuchets or catapults, and you know they have like that in the U.S. I don't know if you're familiar with this, Thomas, but in the U.S. they have what's called the pumpkin chunkin contest. Are you ever aware of that?
No?
Every like Thanksgiving, it's like these group of people get out in this huge field. I don't know where they hold it. It's somewhere in the U.S., but there's like a cannon division and like a trebuchet and like a catapult division, and then they like shoot these pumpkins like into the stratosphere. So this just like kind of reminds me of that. But some of these trebuchets, you know what a trebuchet was? That old like medieval thing. They're super cool. Yeah, they're throwing them like a mile, and so it's fascinating. But it reminds me of this a little bit. But
Yeah.
yeah, so I mean, okay, so depending on the shape of the wind farm, and for me, like sometimes I get in the mindset of like thinking of wind farms as just like a big, almost like a phalanx, you know, like an army formation where it's just like a big rectangle. But they're in practice, they're really not like that most of the time. Where they could be winding up on a mountaintop, like there's some in West Virginia, a couple hours away, that are just going on the mountaintop. And so the icing conditions, I could definitely see it there being like semi consistent from one to the next, but also potentially pretty different depending on like the sun that comes out that day, like where they're positioned. Maybe one gets a lot more sun or a lot less. So I guess like you said, a lot of the operators have to really kind of figure out how diligent they want to be about it.
Mm, exactly. At the end, it's most of the time it's the decision of the owner or operator of the turbine.
Hmm.
And they normally can really they are really good in judging if there is a risk. And on the other side, of course, when talking about this Texas event, of course it might be also really interesting in a greater view or in a higher like a top level view to think about that in terms of a grid operator, as already discussed, to see early icing coming and like affecting several wind parks, and
Hmm.
maybe getting these hours of alert before and turning on maybe other plants or other thermal plants to assist actually the power loss from wind turbines shutting off due to icing.
Yeah, and that's what I think seems to make sense because that's what was so complicated about the Texas thing is that that storm was pretty rare, and obviously what happened was almost it was like a black swan type of event. Just maybe it could have been predicted, but really they just weren't prepared for it, right? Because it was just so out of the blue. But then if you start to think, well, like, all right, Texas is pretty warm most of the time. Like, how much do we really need to put there? Do we really need to spend all this money on all these different technologies? But the idea of, like you said, maybe you just have a couple turbines equipped with sensors where you can say, okay, it looks like something might start to happen. We don't have to outfit all 100 of them and go to that expense, but we could put it on a couple. And now this gives us a little bit of an alert. Like you said, let's get the other types. Like in Texas, it was, natural gas and some coal, and they can start to prepare for it. Now this is not a catastrophe anymore. I mean, is that something that maybe in like slightly warmer climates that you would recommend or see people do? Is just put these on a couple rather than none, and that way you sort of hedge your bets and have some, like you said, some of that predictive power.
It's definitely the first thing you can do, and it's much cheaper than like going for a heating solution or like a whole cold climate package, right? Like you
Hmm.
said, for a region which is normally really warm and didn't happen so far, even the acceptance will not be that high for another, like putting another, I don't know what's the price for heating solutions, retrofit heating solutions in all these turbines. So the ice detection of several turbines and at least get the data of this whole area on certain points I would say that that's a good cheap way for forecasting a little bit and avoiding such events.
Let's talk a little bit about offshore versus onshore. I mean, are you seeing much of a difference? Obviously, one of the things I think that's really interesting that Lasse at WiseTech mentioned was that as wind turbines get to a certain height, they're actually reaching like into significantly colder parts of the atmosphere, which I found really like they can actually like kind of scrape into the clouds, grab some moisture, and start to create ice that way, which I thought that's kind of like mind blowing. But with these getting bigger and bigger, I mean, over 800 feet tall now, you know, and with offshore being such a rough environment potentially, I mean, do you see something, I guess it's like two-part question. Do you see offshore versus versus onshore being vastly different in their needs here, or, and do you see the height really starting to play a different, a new role in icing as we go forward?
The height definitely for ice detection. So we see that also as we have sensors also on the tips that you can see icing especially happening first at the tips, and then sometimes really that you don't have anything closer to the root, which also is sometimes it's like you said, a cloud, like the blade really dipping into a cloud, or most of the times it's also the higher speed that accumulates and aerodynamic effects having more ice on the tip. Offshore, in terms of ice detection, is, I think, a topic where safety is not of a big concern. And it's also seen a little bit different. So we have equipped offshore turbines, but more of in terms of avoiding a service team going there if there is some ice on the nacelle, on the tower. So because then they're going there with a helicopter or with a boat, and they are not allowed to enter the turbine because there are ice and there might be the risk of falling ice down. So they do want to avoid costs for going there for nothing, but not in terms of falling ice, because what happens if the ice falls down, it goes into the sea, and yeah, nobody cares.
Yeah, well, that's interesting. I didn't think about that. So yeah, I mean, if they have to go manually start the turbines, that's a big hassle, and that's a pretty expensive hassle, like you said, because even if they don't go in there, that's, you know, days worth of expense for multiple technicians. Plus, you said, like you said, charting a helicopter, like none of that's cheap. So yeah, it's interesting to think of all the different scenarios that start to play out and whether you should install X or Y kind of retrofit on your, or even at the factory for a turbine. Just say like, yeah, we might have, you know, this many, you know, events over the course of the lifespan where we have to send a technician out. They cost $10,000 a piece. Therefore, we should probably not do that. You know, like, it's really interesting to think of all just the different scenarios that you have to prepare for as a wind farm operator, to just, like I said, just try to feel like what's the most savvy, intelligent, logical financial decision to make. Should we spend X $1,000 on this solution that will prevent these 5 scenarios that will probably happen but may not happen? Like you said, that prediction is really, I think, key. As much as you can say, hey, this is probably how many times that this might happen. So I imagine with these bigger companies that own probably multiple sites, do you see them going more for like the data dashboard, where they just want to start to understand the problem as a whole, so that if they're, all right, we're about to create our, you know, 30th wind farm, we have a good understanding of icing from all these different sites that we've already had, and now we can say, okay, based on where this is, it's sort of similar to site X or site Y, and now yes, let's go for detection, or yes, let's go for detection and heating, or no, or whatever. Is that something that the bigger companies tend to do?
Definitely. So they all have their, as far as I know, they all have their own dashboards. They have their engineers analyzing this data, doing comparison. I mean, there are also big differences between the different OEMs, the different manufacturers of turbines, the different ice detection solutions, different sites. Other effects of icing, I mean, we only talked about the safety things. Then I think that was close to Chicago, talking about a wind park where icing is causing noise, and this noise is then again affecting the village close by. So there are many reasons why operators and owners think about ice detection, especially the bigger companies doing a lot of research, especially the last years in terms of this ice detection and what is necessary and what might not be necessary.
Yeah, that's interesting. One of the companies that we're having on the show in the near future is Ping Services, and they have a sound detection system that they mount on the bottom of the tower, which can tell. And they said icing is one of their potential things as well, where they can tell when there's changes to the blade, whether it's damage or icing or something else, because it changes the pitch and the sound of it, which is crazy to think about. But yeah, I mean, these things are going so fast and they're so big that, yeah, you can imagine that just some little thing that's off makes a really important change to the decibel level that it puts out, which could also just say, all right, hey, we have to stop our turbines because they're too loud now. We didn't account for that, which is, also a big problem. So let's talk a little bit about automation and robotics, which is also a recurring theme on the show, just because it's that technology is taking off. So your sensors are installed both as a factory install and a retrofit. What's that ratio look like right now? And then do you see your installations being done by robots in the future? And if so, how far off is that?
So in 2015, we started, I would say, with 100% retrofit. Of course, no manufacturers were keen enough, I would say, to start from the beginning with a new company and go on our new blades. It's no problem to stick there. So we had to convince operators and owners. So we started with 100% retrofit. And in 2018, got into the option list of the first manufacturer. Last year, the next manufacturer. So we at the moment at, I would say, 30 to 40% of manufacturing based installations and 60 to 70% still retrofitting turbines. Okay. Retrofitting is happening in rope access, via rope access or via platform at the moment. We are already talking with companies like Aerons. I think they have been on the show already. And they have great technology, and we already talked with them if it's possible to install the sensors by their robots on the blades. It's still a little bit tricky as we have, like I said, this erosion protection foil on the sensor, and this one has to go on the blade without any wrinkles. So the process for a human is pretty easy, like sticking a sticker on a window, just squeezing the liquid out and it's flat and it's fine. But for a robot, that's still kind of difficult. But I would say in the near future, making the sensor a little bit smaller, reducing this erosion protection foil, it will be possible to stick that also with a robot on the blade.
Yeah, I guess that makes sense where, the contours of the blade, they continually change as they go towards the tip. So the bigger your sensor is, the more it's going to have to deal with some of those contours. Is that right? And the robot just has a tough time with that?
Exactly.
Yeah. What was it? I used to work in baseball, and we were just trying to put stickers on the front of our batting helmets.
It's the same process.
It's the same thing. It's like we should have the technology to do this. We put like rockets into space, and I can't smooth a sticker on a batting helmet properly without it getting wrinkled. I was very disappointed in myself.
Yeah, but that's the reason why the sensor has to be flexible, right? Because you can't just take a stiff piece of sensor and try to stick it on these different shapes all over the blade. It has to be flexible. It has to be fitable to any position of the blade.
As far as like robotics goes, do you see more of this like ecosystem evolving where, robots deployed to do this or do that, just in general, not necessarily limited to Eologics, but I mean, you guys are, a technology company just like any other. And I'm sure you have to be on like the leading edge, so to say, of, keeping up with what's happening in technology and manufacturing your own products to match an increasingly automated world and robotic world. I mean, is that something that your company, that you guys are really thinking about consistently? Like, how do we fit in? How do we manufacture our next versions or iterations to fit robotics demands or to make inspections easier on drone companies or et cetera, et cetera?
Mm-hmm. So drones is definitely something that is already used. I would not even say that that's maybe the next thing that's already happening. So a lot
Hmm.
of service things and inspections are done by drones. There is also great technology in AI for analyzing the blades, and that's something we use already also for inspecting sensors that have been on blades for several years, how they are affected by erosion, if there are lightning strikes that didn't go into the lightning receptors, how do the sensors look like. So that's much easier with drones and robots with this high technology camera, high resolution cameras on there. That's something we definitely on to, or actually we already use. And then of course robotics for installing the sensors. That's for, I would say, also one of our next big things. If that can be realized, that's also really doing the things easier to get the sensors on the blades. Because at the moment you
Hmm.
need to have this rope access guy. They have to stop the turbine. I mean, it's nearly a day to install a whole system. That's not a lot, but it also is of course better to do it in 3 hours, for example, right?
Yeah, I think that's everyone's goal, is just moving faster and making it safer and getting people off the blades themselves, because rope access is, even though it's, the safety protocols are excellent, it's still just dangerous work, right? It's tough work. So what's next for you all? So I know you have another product you're potentially rolling out soon. Can you tell me a little bit about that? Because it seems like when you have this sort of sensor platform, that you could potentially do different things with it, right?
That's true. So we see the sensor definitely as a platform. Ice detection was the first thing. Temperature measurement is on there. And the next big thing, so to say, for us will be in June launching pitch angle misalignment detection. So we also have acceleration sensors on our sensor platform, and giving us the possibility to detect and especially continuously measure pitch misalignments and pitch angles during operation. And that's the new thing, doing this pitch measurements continuously during operation in all states of the operation. So not only at, for example, 5 meters per second, but also up to 20 meters per second.
So we've talked about yaw misalignment on past shows a little bit, but we haven't talked really much about pitch angle misalignment. So can you just give me kind of an overview? I mean, to me, it seems like, they install the blades once. Like, why would they wander off out of misalignment?
Majority of things happen is actually due to service or to software updates of the turbines. So really changing something at the turbine over their lifetime, and suddenly you have like one blade going off with 0.5, maybe 1 degree, which is really not a lot, but talking with 1 degree of misalignment of one blade, you can expect an AEP losses of 1 to 3%. So and
Mm-hmm.
that's again a lot. And why that is happening is actually maybe the pitch strategies changes, or service teams um, leave some sensors uncalibrated and so on. So there are actually many reasons why that can happen. And I also know now a lot of companies that started to, after building turbines, doing pitch measurement right after the commissioning, as already, or at the commissioning phase of the manufacturer, issues or failures can happen that result in a pitch misalignment.
Okay, so once they update software or making some kind of change, that's when they can get off. And like you said, 1 degree is so small, where if you don't notice, you're just like leaking power for the indefinite future.
Additionally, you have all this stuff like individual pitch control, automatic load control. So the modern turbines start to change their pitch during one rotation. So there is a lot of pitch system doing their work there. They also can have failures. So maybe they're not, like, one of these engines is not exactly operating correctly, 100% correctly, and suddenly you have a 1 degree off compared to the other blades.
And then would this sensor be combined with ice detection, or would it be a separate sensor? Probably like just like different customers. Obviously, it could be the same customer, but How do you, is it a combined thing or is it going to be separate?
The sensor looks the same, although the ice sensor and the pitch sensor are two different things. So you have, especially in the positions of the sensors on the blade, they have to be different, but the receiver can be the same. So it is possible to have a kind of combined system, but you can also use each system on its own.
And you're rolling those out this summer, is that right?
Exactly. So in June we have the official launch, and starting with August they will be able to be installed on all the blades of our customers.
That's awesome. Well, I'm sure you guys are excited about that new product launch, and so much goes into the development of all that stuff. So it's always like a nice milestone, I'm sure, for your team to see it finally get out the door and start to get on, on those turbines.
Yes, so we are all really excited, as it was also a really long way to go for this new product. But I think we did a great job, and we have really good results from 2 rounds of prototype installations. So we had eight turbines last year. We have another 4 turbines beginning of this year equipped with systems, and everything looks really promising. So being really excited for it.
And your ice sensor is certified by DNV. Is that something that do they certify, like pitch alignment? Is that something that you guys be seeking when this rolls out, or will it roll out with certification already?
It will roll out with certification, and I mean, it's not that important from our perspective as with the ice detection. As with ice detection, it's a safety thing, and you have to prove that it works because it's safety, right? For the pitch angle misalignment detection, it's more like a third company validating that it's true what we tell we can do, so that the third company is validating our sensor.
Well, that makes sense. I mean, we had a couple DNVN, well, at the time, I think it was still called DNVGL engineers, Alex Byrne and Matt Malkin, and I mean, brilliant people. So when, a company like that's validating your tech, I mean, I think that's always lets people adopt it quicker without less, with less worry, because they know this thing's been checked by some of the best in the industry. So
that was the idea behind it, exactly.
Yeah. So Thomas, we really appreciate your time today. How can people follow up with Eologics and keep pace with what you're doing?
So it would be great to follow us on LinkedIn. So we all the great news, the launch of the new product, case studies. We have everything on LinkedIn, of course, also on our webpage. That would be great. We also have there a very interesting white paper if you want to get to know much more about ice detection. Everything is explained in there. The same thing will be for the launch for the pitch event. So it would be great to have a look at the webpage and maybe follow us on LinkedIn.
Okay. So for those of you listening or watching here on YouTube, as always, we'll put links to Eologics and their LinkedIn page and all the social places you can follow them in the description below. Again, whether you're on iTunes, Stitcher, Spotify, or YouTube, wherever, you can easily click through and follow up with them. So Thomas, thanks so much for being on the show. I really appreciate it. It was a really interesting conversation. And like I said, another angle to this whole wind turbine blade icing, kind of issue that we've been talking through.
Thanks a lot for the invitation.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install strike tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions. And we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.